Hello, in this video I would like to share with you the 4 key characteristics of good scientific writing. And they're the 4 C's. And in the first level, you need to write clearly and concisely. And that's the very basic level of writing in general. You have to use simple language with no ambiguity. Okay? And then one level up is that you have to write coherent pieces. Now, lots of times we find ourselves writing excellent paragraphs, explaining things very well on their own, but when you put them together, they can't really connect with each other as a coherent whole. And that's the second level you need to pay attention to, is you have to make sure that all the ideas and paragraphs are connected as a coherent whole. And then we go another level up. You have to be critical. Being critical means that you have to write, you have to demonstrate a critical analysis of the literature, demonstrating both the strengths and weaknesses of the evidence available, and then synthesize, make your arguments, articulate your hypotheses very clearly. And then the final level, the expert level, is that your writing has to be captivating. At the end of the day, science is for other humans. Science is objective, it's about facts, but you have to deliver it in the way that will connect to other humans. You need to learn to tell a story, to make drama, to demonstrate the ingenuity of your science, and to attract other people's attention. Okay? Let's dive into these 4 characteristics and see some examples. So the first one is that you need to write clearly and concisely. And I would like to introduce 3 simple techniques. One is to choose simple words, no jargons. Second is you need to write short sentences instead of long, complex sentences. And the third one is to use active voice where appropriate. The first one, choose simple words. And this is quite simple, so I'll give you a few examples of difficult words versus plain words. For example, you might have, instead of saying presuppose, and it's easier if you just say assume, instead of saying as a consequence of, which is 4 words, it'll be easier if you just say because, and it's actually more frequent and more accessible to an average reader. And the third example, neural oscillations, that is a specialist term. And if you're writing for specialists, it's perfectly fine if you say neural oscillations. But for a lay audience, you might want to say something like brain waves, or at least you want to explain what neural oscillations are before you keep using that term. And the next category of simple versus difficult is that you want to use verbs, actual action verbs, as opposed to normalized verbs, which are noun forms of these verbs. So instead of saying I carried out an analysis of the DNA sample, you just say we analyzed the DNA sample in a certain way. And the reason for that is that when you use action verbs, it actually engages your brain's motor system better. And this is, if you check the literature on embodied cognition, and it would tell you that when you read verbs, certain parts of your motor system actually gets activated. So you feel that you're engaged with the sentence, but when you use the nouns, you lose that kind of motor engagement. And also, usually, if you just use the action verb, the sentences they tend to be shorter. So here's an example. The researchers completed the implementation of this new method. So instead of saying completed the implementation of this new method, it'll be easier if you just say the researchers implemented this new method, right? And the next one is avoid hedging verbs. These are sort of tentative language you will use in writing. So instead of answering a question directly, and you would say use very soft language, appear to be there appears to be an effect. The effect seems significant. So in scientific writing, you want to be precise. What if you say but it's either significant or not significant. You can't just say seems significant. If you don't have to use these verbs, use the concrete action verbs instead. Lastly, you want to avoid vague qualifiers. Science is all about precision. You don't want to describe something using any of these qualifiers like perhaps, very, quite. Oh, the result was quite significant. That doesn't sound very right? You have a threshold for stating whether something is significant. Well, it's either yes or no, right? And you wouldn't say, oh, the hypothesis is basically true. Well, maybe sometimes partially true, but you have to specify exactly which part is true, which part is not true. Avoid ambiguity, and that's very important. So that's some examples about choose simple words. And the next technique is about write short sentences. Now, here I've got an example of what I think a long sentence. The category of literary fiction has been contested on the grounds that it is merely a marker of social class, but features of the modern literary novel set it apart from most best-selling thrillers or romances. I would suggest that it would be better if we write these long sentences into two short sentences. Basically, what they're trying to say is literary fiction is not just a marker of social class. Its features, in fact, set it apart from best-selling thrillers or romances. Well, I add in fact here because I feel, in my mind, I feel that there has to be some rhythm change. But you can write it in your way. You don't have to go through these lengthy words, difficult words and phrases to express that meaning. Not good for science communication. That's one example. And then if we have to give you some specific advice, then I would say you want to limit the use of prepositional phrases. So sometimes you write one sentence, but you have a very long prepositional phrase at the beginning in this particular example. In the first trial conducted in this experiment, there appears to be blah, 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 blah. And obviously, there are multiple problems with this particular example because you use a hedging verb. There appears to be. You can just say there is, right? And there's also a normalized verb, so a demonstration of something. Then it will be easier if you actually just write the sentence using the active verb. But anyway, so prepositional phrases. So it would be better if you remove that prepositional phrase and then integrate all the information into one single sentence. And it would be easier if you just write the first trial demonstrated the effects of combining the substances. Okay, and the next one is you want to avoid subject-verb separation. Typical way of processing a sentence is that we will read the subject and then it's immediately followed by the verb, right? And then if you look at this example, the subject DNA is so far away from the actual verb. So basically the main sentence here is DNA contains genetic code. But then the author inserted a long sentence of information to explain what DNA, where DNA can be found, which is fair enough. But you don't want to break the main sentence, and it would be easier if it reads better if you write DNA contains genetic code and is found in body fluids and soft tissues and all the other stuff, right? So that's for writing short sentences. And the third one is to use active voice. And there's a myth in scientific writing that you have to use passive voice just to, appear very objective. You're talking about facts, you have no involvement in the facts. The facts are just there and you have to present it in a passive way. And this is just wrong because it doesn't engage your reader. An active voice will give you a sense of agency and action. So here's an example of passive voice. So instead of you analyze something, then you simply say, an analysis of the prefrontal cortex shows the patient's inadequate emotion and behavioral regulation. Right, okay. So two problems. One, passive voice, an analysis. Like what? The analysis just happened by itself? And the other one is the normalized verb here, behavioral regulation. So you have to think about, maybe I can write a sentence that explains something regulated something else. So, for example, you can write it this way. We analyzed, active voice, analyzed. It's a verb, not normalized noun, verb noun, okay? We analyzed the patient's prefrontal cortex and found that he inadequately regulated his emotions and behavior. So when do you use active voice? Basically, you need to use active voice for all the actions you are responsible for. You did the literature search, review, then explain what you found actively. You design an experiment, explain the methods actively. You analyze the data, explain the results actively. Your thoughts about the results in discussion, well, discuss actively. The only thing that you possibly have to use passive voice is like the universal fact, like the earth is round, or I don't know, the light speed of light is this much. So that's the principle of when you should use the active voice and passive voice. You want to focus on the objective information. You're not trying to claim your responsibility in this matter. Now that's for the first clear and concise. I know there are two C's, but they are part of the same thing. Basically, you have to write clearly. If you can't write clearly, then it's bad from the beginning. But once you can get like each sentence right, clearly and concise, then you have to be worried about how they connect to each other to form a coherent whole. And then when I try to explain this matter, I always use the fine dining analogy. So let's say you go to a Michelin star restaurant and you order a 3-course meal. You have a very nice starter, some kind of I think this might be a scallop with some puree and whatever, peas and stuff. And then you have the fish for main, and you have some chocolate for dessert. All very nice. The 3 pieces sing together. But if you go to a different restaurant, the foods are cooked very well to a Michelin star standard. However, the starter is some prawn crackers. The main was some Italian pasta. And the dessert is some kind of a sesame rice pudding ball thing dessert. They're all very tasty, but you're just really confused because these 3 things, they don't belong to one meal, right? And that will be an analogy for incoherent writing piece. I mean, each paragraph or each idea is presented really, really well, but they don't connect with each other. Okay, so to give you an example. So this is an incoherent piece of writing. So international policies like the Kyoto Protocol have emphasized the need to increase efforts to reduce greenhouse gas emissions and increase carbon storage in non-atmospheric pools. Okay, so international policies. Harvested wood products, and you're like, hang on, how did you go from international policies to wood products? I mean, how are they connected? So it explains what the harvested wood products are. They include all wood materials that leave a forest after harvest. So the first and second sentence, they're just like disconnected. Like what's the relationship between them? Until you read the third sentence. Not only are they important for certain sectors of the economy, such as shipping and manufacturing, but they also serve as terrestrial carbon stock. This is saying these wood products, actually it's a carbon stock, right? They're useful and they also serve as a carbon stock. And now you understand, okay, well that's their relationship. So it would be better if you actually can make all these sentences connected. For example, you can say international policies like the Kyoto Protocol have emphasized the need to increase efforts to reduce greenhouse gas emissions and increase carbon storage in non-atmospheric pools. First sentence, fine. Now, second sentence, one way carbon is stored is through harvested wood products. And then you explain what they are, which include all wood materials that leave a forest after harvest. These products, which already play an important role in shipping and manufacturing, now have a role to play in advancing global environmental initiatives. That sounds a lot better than the first one, right? Everything makes sense. So what else can we say about that? Well, I guess the important thing you just need to, when you finish your writing, you read it yourself or you send it to your friends and colleagues and see whether your ideas actually flow and resonate with each other. whether they form a coherent piece. In terms of specific techniques, I suppose one is you have to be aware of the connections between different ideas, especially if you're changing subjects. They probably belong to different paragraphs, and you're going to have to connect different paragraphs with certain either explicit connections or something. There are certain limitations in the methods because da-di-da-di-da, and you explain what they are, or this literature proves that something is true, however, and you want to stay whatever next. So you can use these explicit connectors, or you can do it implicitly, which is a bit of an art. As long as you ensure there's a logical flow running through your writing, it's great. And another thing, which is not, it's big and small, I don't know, it's parallelism. I call it parallelism, I don't know whether it's the right word for it. Basically, if I start this talk with concise, coherent, critical, and captivating, I will have to explain them in that exact order. I should not explain concise first and then jump to captivating and then critical and then coherent. And that's not very coherent because the order is all wrong. And I see that in students writing all the time where they introduce something A and B with A first and then B later. And then 2 paragraphs later, they talk about B first and then A, which I think at least is an irritation. It annoys me. Think about your reader. Keep it consistent throughout your writing, so your reader will not get confused. Okay, parallelism, and that's for being coherent. The third one is to be critical. So when you read different kinds of scientific writing, and you will find that certain examples, they might be more descriptive and some others are more critical. So what is being descriptive? It's basically you're just stating the fact. You're presenting certain information. Maybe you can present the information in certain structure, certain logical order. It's all very good. But the trouble is that if you're not developing certain argument out of your information, then it's kind of useless information. It's almost like, oh, why don't I just go to Wikipedia? I mean, they've got all the information. Why should I read your piece? When you do scientific writing, the goal of scientific writing is not just to present the information, but also the information you present serves the purpose for you to make an argument. So every piece of scientific writing, you have to make an argument, and therefore you have to write critically, meaning that you have to transform the information you have and make your original contribution. You have to demonstrate and identify the strengths and weaknesses of the information you have presented, and make create your own hypotheses or predictions or arguments about this topic. And then so you generate something new rather than simply just reorganizing information. I mean, we're not Google. Google doesn't generate new ideas. It simply organizes all the information in the world, which is very helpful. But Google is not a scientist. So how can we be critical? There are a few steps that you can consider. So first, when you present certain pieces of evidence and argument, then you need to evaluate them, both in terms of their strengths and weaknesses. Identify key positive and negative aspects you can comment upon. You can recognize the good things and then recognize the limitation. And then you'll propose how you will address the limitation to make better, to contribute to the existing debate. Okay, and you want to assess the relevance or usefulness to the debate, whatever debate you have. Certain theories, and they say, oh, this schizophrenia works like this, and the other person says, well, no, it works like that. And then both sides will have some evidence, and you recognize, okay, this evidence is good, but they have some problems, and the other side is also meaningful, but they also have their own problems. Okay, what should I do? I would say I will reconcile the differences from both sides and integrate them into something new. And that's the sort of things you want to do. And of course, we have the critical evaluation workshop, and then you practice all these skills, and then your writing should reflect that. Here's an example of a descriptive writing. So there are several treatment methods to auditory verbal hallucinations. Okay, for cases which causes of AVH are believed to be due to sleep. I think the writing is a bit not very smooth here. Due to sleep deficiency, are basically saying ADHD that's not caused by schizophrenia, but caused by these things. And patients are normally given these medications like antidepressants or whatever, so they treat these symptoms, so their hallucinations will go away. So they can help them restore to normal mental state, and so the frequency of the ADHD episodes will decrease. Patients who have ADHD due to schizophrenia, so it's different kind of cause, and of course they're treated differently. They're giving antipsychotic medications, and these medications act as inhibitors. This help address the cause of schizophrenia along with symptoms. So you can see this piece of writing has structure. So they introduce two classes of treatment. You take different kinds of medications to treat hallucinations of different causes. And it's all fine, but then what do we do with that information? If I'm not an expert in hallucinations or schizophrenia, I wouldn't immediately recognize, okay, so what do we do then? Is that a problem? That's what you need to put in writing. Okay, and let's see a critical example. So there are a number of inherent methodological difficulties in evaluating treatment efficacy in this area. I'm not sure which area, but anyway, this has contributed to controversy within the research literature surrounding treatment outcomes for this group of offenders. Okay, some kind of offenders. Firstly, okay, there's some structure. Firstly, while there is no doubt that the primary criterion of treatment success is a reduction in the rate of reoffending, reconviction data does not in isolation provide a realistic representation of actual levels of reoffending by this group. Okay, so this is something critical. So it recognizes, yes, the traditional way of measuring reduction in reoffending is fine, or treatment success, efficacy, it's fine. However, and it recognizes the data is probably not very realistic. And then it go on and explain it's well established that there is a discrepancy between reoffending and reconviction rates. Okay, so some evidence to back your argument, and indeed a significant proportion of offenses committed by offenders are either unreported or do not result in offender being committed. Okay, so this is a critical example. So you actually identify the limitations in the current method, and then propose, okay, what is the problem and what is the evidence to support my argument? And I can imagine they will go on and explain, okay, well, in my case, I will propose to do this instead. Okay. But of course, I mean, no writing is perfect. You can always find some problems. I mean, this person's written firstly, but there's no secondly or next somewhere. So if you write firstly, a reader will automatically expect, okay, there's going to be multi-point arguments here. So I'm just going to find a first and second and a third. But here they don't have that. And also there's certain writing like it's well established. You'd rather just say, you don't write in passive voice if you don't have to. Okay. So that's the critical example. The fourth point, captivating, is a rather difficult one. So all I can tell you is that if you have achieved the first three, then you are probably writing very good scientific papers and research proposals. But if you can make it a little bit better by telling a compelling story, then your writing is going to be perfect. So what does it mean by a compelling story? So you have to be human. So if you can tell a piece of science in a human way, then people can connect to it. Okay. And the second point is you want to create some sort of drama. And a lot of times, people might assume something is true, and then the groundbreaking research comes along and then destroys everything that we believed before. Like in the beginning about like the Earth is the center of the universe, or the Earth is flat. And if you can demonstrate dramatically how this new piece of research completely transforms the way we see things, then that's a compelling story. And the third one is you want to demonstrate the ingenuity of science. Sometimes you get studies where they use very, very simple design, like the graphene story in Manchester. So how was graphene discovered? Well, it's So graphene was created by sellotapes. You know, you tape a piece of graphite multiple times, and you have thin layers of carbon on the tape, and you tape it a few more times. Eventually, you're gonna get like a single layer of carbon, and that's graphene. There's nothing fancy, but it's dramatic. It's ingenious because, well, who'd have thought that you can just create something, this new material, using such low-tech technique? You know, it didn't use laser or some kind of a fancy machine. It's just sellotapes. So that's the ingenuity of science, and that's a compelling story. And there's some other tips that I got from other people. You have to start with your writing with a good opening line to get people thinking, and you want to link it to the current issues in academia or popular press. Let's say if you talk about something about decision making, or if you're studying psychopaths, and you might want to link it to the U.S. elections at this very moment, whether Trump will continue his presidency. These are the current issues, and it might be interesting, or people can see how your research might be relevant to their lives. Okay, and the final one is you want to conclude your science in context. And it's not enough if you just say what it is. We found that there is uncertainty around quantum mechanics. If you can conclude your science in context, make it relevant to your audience in terms of how their lives might be influenced by this research, then put it in context. And so to help you learn more about how to write a good scientific, how to improve your scientific writing, and there is a series published by The Guardian on secrets of science writing, and then you have a collection of articles talking about various science writers talking about how they produce their scientific writing. So you might want to check it out. So that concludes my little presentation. It's a bit long, but I hope it's helpful. And what's most important is that you remember this point and try to put it in practice. And practice makes perfect. Thank you very much for watching this video. I see you next time.